All right, geometry students, we have 1.6, classify polygons. Once again, lots of vocab to start us out with here. Remember, you do not need to copy these word for word. You can copy enough to make it make sense to you, and most of all, you can just draw a picture if you want, okay? Because pictures really will speak to your brain a little bit clearer, and we don't need all this mumbo jumbo if we're just trying to make sure we know this word relates to this thing. And I will tell you too, like this definition I have for polygon, it's on the next page as part of the notes. So don't get over eager and saying, I got to get all these words copied. What I'd really like you to do is just listen as I go through them and make sure you understand those. If need be, you can pause the video so that you can copy what you need to. But again, make sure you just understand what I'm saying more than you're worried about getting every little word down. So we're going to deal with polygons, okay? Lots of polygons in geometry. I'm going to be honest. We're probably not going to get to all the polygons as fast as you think we should. We spend a lot of time on triangles, lots of chapters, in fact, on just triangles. So what I'm giving you today is not like all this information we need on polygons. It's just a really general overview of making sure we know on the vocab when we're talking about something, and some general features of all polygons, okay? And I do want to stress too, polygon itself, anytime we see the word poly, the prefix poly, it means many, okay? So this is a generic category for all these shapes, okay? It's not a name of one specific shape, but it is a generic name for a lot of different shapes, okay? So a polygon, and you're going to notice I often draw my polygons this way. I dot to dot them, okay? I put some dots, I connect them, and that creates a polygon, okay? Notice it's closed. All the lines go together. Formed by 3 or more line segments, I have segments. Each side intersects exactly 2 sides, one at each endpoint. No 2 sides with the same endpoint are collinear. Please don't worry about that. When I get to the next page, I'll do more explanation on that, okay? So what you see here is sides, okay? Each of these line segments is a side, okay? I see a dot where 2 sides come together. That's a vertex, okay? Those are what I need you to know more is there's a side, there's a vertex. And I do want you to notice that if there's more than one vertex, we call it vertices. That X becomes a CES at the end, vertices. So don't get scared by that word. It just means more than one vertex, okay? Now, the next two go together. I will tell you, if I'm given this lesson in class, I've got a lot of polygons on top of the board, or I should say above the board, that I have hanging on the wall. I like to point out to them. I like you to see the difference between them. Convex and concave polygons. It's one category. We either put things in convex side or the concave side, okay? Convex means all sides are formed by lines where the points on the exterior of the polygon. That definition does not sound very clear, but let me give you a quick picture and maybe this will make a little more sense. So I have a polygon, okay? I'm going to make 5-sided right here. And what this means is when it says all the sides are formed by lines on the exterior of the polygon. So if I extend this line, and I extend this line, and I extend this line, and extend this line, and finally extend this last line. Notice every one of them, the lines keep going on and on and on outside of the polygon, okay? That's convex. All right, now let me try a concave one. And again, you're at the mercy of my art skills, which are not always great, okay? So just be warned, that's what you have to deal with here. Okay, concave. So let me draw you a concave polygon. Okay, there's my concave polygon. For most of you, you're like, well, it caved in. And I'm going to be honest, that's how I remember it. It caves in. But let me go back to this definition they give us of that we have a polygon with sides that lines have a point inside the polygon. Okay, so I start tracing these. I make this into a line. I make this side into a line. I make this side into a line. But look when I make this side into a line. All of a sudden, I cross inside my polygon. The same thing with this one. My sides, when they cave in, they create these lines to come into my polygon. Because of that, that's a concave. So that's how that definition works, okay? But I just want you to think of any time the shape caves in, okay? Here's another one, right? A bubble letter. It caved in, okay? So for the most part, in geometry, we deal the most with convex. almost every formula you know works with a convex polygon. It doesn't work with concave polygons, but it's important to know there are both, okay? And sometimes the best way to deal with a concave polygon is to break it apart and turn it into convex polygons. And as we get to those, I'll show you. So don't worry about, oh no, I have to remember all these things. No, it's okay. Okay, end polygon. A polygon with n sides. One thing I want you to know is when different variables are used, sometimes in math, they're very consistently used for the same thing. N is one of those. If you see n, it basically stands for a number of sides, okay? So this is one of those variables you see a lot that goes with sides. So, and when we don't know the name of a polygon, or more specifically, we don't know how many sides a polygon has, we'll call it an n-gon. Okay, the next three, big words in geometry. We use them a lot. If you see them, you automatically have to picture in your head, what does this mean about the polygon? So please make sure you know the next few. Okay, equilateral. All sides of the polygon are congruent, okay? So if I draw you one of these, and I'll show you two using our marking, so I have all the sides of this polygon are exactly the same. So you'll see all these tick marks, remember our congruent marks? That means that polygon is equilateral. Okay, the next one is equiangular, which means all the inside angles of the polygon are congruent. So I can draw you an equiangular. All these angles are exactly 90 degrees. So every angle in there. Just a quick spelling thing, and you already know spelling is not my forte. I'm not great at it, but I do want you to notice in this word, equiangular. There's no L in the middle. It's just equi. E-Q-U-I, okay? So there's no L there. Even though we think of the word equal, ends with an L, we see it when the top there, on this one, equilateral, the L actually is with the lateral. Here, the L doesn't appear because angular doesn't have an L on it, okay? So if you throw it on there, I'm not going to mark it wrong, but I just want to bring it to your attention that there's no L in that word until the end with the lur on the end, right? Okay, so very important. I'm going to find a new highlighter color, I guess, because I can. Regular, okay? I can't stress to you enough. This little word sneaks into sentences, and it is so very important. You need to know this word regular. We need to use it. We need to know what it is when it's being used. This is a polygon that has both equal sides and equal angles, okay? So I have 4 sides that are equal, and I have 4 angles that are equal. That's what makes this shape regular. So keep in mind, if they squeeze that tiny little word in, regular, I can automatically mark all my sides equal and all my angles equal. And that's a really big deal when you're dealing in geometry, okay? So lots of vocab. Probably the most important ones on this whole thing are the last 3, equilateral, equiangular, and regular. Let's flip the page and get some more notes here. All right, so identifying polygons. All of this box is just telling you what a polygon is, okay? Sometimes they give you something so quickly that we don't realize what it really means and how that works, okay? In geometry, a figure that lies in a plane is called a plane figure. Okay, so think about that. It used the word plane. It means that it's a flat, two-dimensional, okay? Obviously, a plane goes on and on and on forever, but a figure, when we put sides on it, it's limited to inside that, but it's going to be flat like a plane, okay? It is a polygon here. That's what we're filling in here. Polygon is a closed plane figure, closed, okay? It is formed by 3 or more line segments called sides. Each side has exactly 2 sides. Each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. And right now, just copy my words, and I'm going to show you a little bit more late what these mean. Each endpoint of a side is a vertex. And we have the plural of vertexes, vertices. Okay, I'm going to stop there and go through a couple of these things. You will have questions on your homework and your next test that will say, is this a polygon? The easy answer is yes, but if you say no, I'm going to ask you, well, why not? Why isn't this a polygon? So in the margin, I gave you a list of reasons a figure is not a polygon. Okay, one thing is maybe it's not closed. Well, what would that look like? Okay, So I'm going to give you more examples. So if I see a figure like this and they just stop the drawing, well, they didn't close the figure, so it can't be a polygon because when you think about a plane going on and on and on forever, this could keep going on and on forever in parts of it because I didn't close it off. So it's not closed, it's not a polygon. What if you have something that has a curved side? Okay, something like this. There's no curves allowed on a polygon. A circle is not a polygon. You can't have that curved edge, okay? And this is kind of curved line. I should probably say curved edge because there's no such thing as a line that's curved. Okay, this interior line thing, okay? So something like this, maybe, you see the little house drawing, okay? This one does not go with this part. Each side intersects exactly two sides, one at each endpoint. So if you think about this, this side right here on the left, okay, it touches the bottom side, that's one side. It touches the slant up to the roof, that's two sides. But if I put an inside line there, that makes three sides that are trying to touch this one vertex right here. And that one vertex cannot touch that many sides. Okay, or this side here is touching three different sides. That's where that violates that. So if there's an inside line, it's making this part here that more than two line sides, that's violating that part of the rule. The other one has lines that cross. And if I try to tell you this whole shape is a polygon, you'll notice here that I have these lines inside that cross. That's not good, okay? And the reason that's not good is it says that no two sides with a common endpoint are collinear. So if this was a side and this was a side, these are all one big line or line segment. And I'm not allowed to be collinear or on the same side. So as soon as I see this point that has some intersection points that makes things cross each other, we end up not being able to have sides with the common endpoint not collinear. So that's the reason we can't have those. To be honest, what the reasons I have in the margin, that's a perfectly acceptable reason to give on a test or quiz or homework assignment why something is not a polygon. Okay, the other thing we need to talk about is naming a polygon. Okay, so we're over here. A polygon can be named by listing the vertices in consecutive order. Consecutive means one right after the other. So basically what you need to do is we're playing dot to dot, okay? And you choose where you start. And it does not matter where you start. This is not the alphabet that you have to start right where it is. But once we choose our starting point, it's going to affect the rest of our answer. So I'm going to say right now, I'm going to start at D. So if I start at D, I could name this polygon D, and now I'm going clockwise, E. The next one has to be A. The next one has to be B. And the next one has to be C. And if I keep going, I go back at D. Well, I don't want to list that twice, so I'm done. That's one way I could name that, okay? But I do want to stress to you, you don't have to go clockwise. I could start at D and go the other way. So I could go D, C, B, A, E, and then I'd be back to D. So I could go around this way. It doesn't matter where you start or which direction you go, but you must keep those vertices exactly in the order you see them, one way or the other, okay? You can't mix those up, okay? When we named a plane the other day, we could choose any 3 points and name it, and I told you the order didn't matter. And it doesn't matter when you name a plane. But when you name a polygon, you have to choose one vertice and keep rolling in a circle, either counterclockwise or clockwise, until you get back to the point you started with, okay? No jumping around on naming a polygon. Okay, going down to identifying polygons down here at the next example. It says, tell whether each figure is a polygon and whether it's convex or concave. I'm going to add in there just so we get the practice. If it's not a polygon, say why, okay? So the first one, yes or no, is that a polygon? And the answer is not a polygon. And they did already write our reason down. Some segments intersect more than 2 segments, okay? Or the easy way to say that not a polygon, I could say inside lines, okay? And we don't want inside lines, so that's why that's not a polygon. Okay, for B, is B a polygon? It has sides, lines. I'm liking it. I say, yes, this figure is a polygon. And the question is it concave or convex? Well, it looks like everything's pointing to the outside, nothing's caving in, so I'm going to say convex. For C, is this a polygon? Does it fit the rules of polygon? It's closed, no curves, no interior lines, no lines across, so I'm going to say yes, it's a polygon. And then the question is it concave or convex? This one looks like it has part that caves in, so I'm going to call that concave. All right, number 1 down here on the checkpoint looks like home plate. Is that a polygon? Definitely fits all the rules. Is it concave or convex? Nothing caves in, so we call that convex. All right, on number 2, is that a polygon? I agree with you, not a polygon. And why isn't it a polygon? And I would say because it has curves, right? As soon as I see that edge that curves, I have to say no, not a polygon. All right, on to page 3. Okay. Now, I have this big chart on the margin here, and it's all filled out for you now that you see it here, but when you look in your notes, I think it's not filled out, and I would have gone through these one at a time with you. I don't know if you'd call it torture or not, but just to check to see if you knew the name already. The important thing is when we go through this is make sure when you name a polygon that you name it its most generic name possible as far as based on its number of sides, okay? So 3 sides are easy, it's a triangle. But when I usually say 4 sides, a lot of students will start saying rectangle, trapezoid, square, rhombus, all these names. We need to step back and just say, no, if it has 4 sides, that grouping that all have 4 sides are called quadrilaterals. And think about it when you ride a 4-wheeler. Some people say, well, I'm riding a quad because it has 4 wheels. Okay, so quad goes with anything with 4, so quadrilateral. 5, like that 5-sided building out in Washington, D.C., the one that got attacked on 9/11, is the pentagon. Anything with 5 sides is a pentagon. 6 sides, I remember this because it has the X in it, 6 and hexagon, okay? 7, sometimes the prefix is sept, S-E-P-T, but for polygons, we call it a heptagon. 8 is octagon, octopus, octagon. Anything that has 8 starts with an OCT. 9 is a nonagon, okay? They don't want to say ninagon. I guess it just doesn't sound good, so it's nonagon. 10 is decagon. A decade has 10 years in it. A 10-sided figure is a decagon. 12 is a dodecagon, okay? Yeah, I guess I should lift it just a bit more. 12 is a dodecagon, so it mixes do, which is for 2, and dec, which is 10, and makes it a dodecagon. Now, I need you to realize that these names in this list, I'm going to hold you responsible for knowing. If I ask it on a test or quiz, you need to be able to tell me what the proper name is for something that has 10 sides. Or more specifically, if I talk about an octagon, you need to know I'm talking about an 8-sided figure. So this is one of those sets of things, if you don't know these words very well, maybe make some flashcards because you need to know them for the rest of geometry, okay? Now that I've given them to you, you're held responsible for knowing those names. Now, I do need to highlight this last one because this is important, okay? It's the n or n-gon. This is saying if I don't know how many sides something has, I'm going to call the number of sides n because that's my unknown number. N sides, or we call it an n-gon. What I also want you to know, though, is if the number is not on this list right now, you do not need to know a specific name for it, okay? So if I have something with 15 sides, I could just call it a 15-gon, okay? Something with 294 sides, I could call it a 294-gon. The other one I want to point out to you is I didn't put in 11 sides. That would have been in there between the decagon and the dodecagon. So if there's 11 sides, you can just call it the 11-gon. Okay, why don't we use something with 11, or why don't we know the name of it or use it very much? And the real reason is there's just not a lot of things out there with 11 sides on it. So it hasn't become a popular name that we need to know, so we don't. Now, I always say that, and then I realize too, I probably should point out, there's a chance you have something in your house that has 11 sides on it. Okay, any of you that have ever gone and used a pop machine or something and you try to put a Canadian quarter in and it rejects it? And you're like, how does it know I'm using a Canadian coin and not an American quarter? How does it know? Well, go find one of your Canadian coins. Did you know that a Canadian coin is not a circle? All Canadian coins actually have 11 sides. They're polygons. They are not circles. So that's how your vending machines know that you're using a Canadian coin. They can't see it. They're not so smart that they're like, whew, this one doesn't say America on it. God bless America or whatever. It doesn't have an eagle on it. Nope, that's not how those vending machines know. The vending machines know because of the actual sides of that coin. So if you have a chance, go find a Canadian coin and see if you can count the 11 sides on it, okay? All right, so let's go ahead now and go through our notes. What I want to point out here is when it says classify, okay? Anytime I see classify, that means I need to put it into a category. And in this case, I need to classify it by its sides. So I need to look at my list and say, because it has so many sides, what would we call this thing? Okay? And the other thing we're going to do is say if it's equilateral, equiangular, or regular. And let me give you a heads up. You can only use one of those answers. You may not use 2 or 3 of those answers in your answer choice. I want one of those words, okay? So first things first, we come over to this shape and we need to count the sides. When I count them, I start at one side and I kind of mark it so I don't overcount, right? So I have 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I have 8 sides. And when I have 8 sides, I call that an octagon, okay? I'm going to leave myself a little space though because I'm hoping to use one of those other words. Now, the question is it equilateral? Does it have 8 equal sides? Well, all of those had a tick mark, so I'm going to have to say yes, they were all equal. Is it equiangular? Are all the angles marked congruent? And if I look, every one of them has one little angle mark, which means yes, those are all, okay? If I get a yes for equilateral and a yes for equiangular, my one and only answer I'm going to give is regular, because regular says both of them are true. So you're only going to use one or the other if it's the only answer. But if it's both, you're going to say regular. Okay, next question. The head of a bolt is shaped like a regular hexagon. The expression shown represents side lengths of the hexagonal bolt. Find the length of a side. Okay, so only 2 of these sides are marked. Don't forget, they squeezed in this one tiny word up here. The head of a bolt is shaped like a regular hexagon. As soon as I see that word regular, I can come through and mark every one of these is exactly the same. So what do I know about these 2 sides? Well, those sides are going to be congruent, right? Because that's the meaning of regular, okay? I have 2 sides congruent, which means part equals part, okay? So one side, 4x plus 3, is going to equal the other side, 5x minus 1. And I'm going to be able to solve for x. They didn't give me a lot of room here. Subtract 4x, and I get x. Add 1, and I get 4. So it looks like I get x equals 4. It didn't ask me for x, so it said find the length of the side. So I'm going to go ahead and plug 4 in for my side. So on the top there, 4 times 4 is 16, plus 3 makes 19. So it looks like one of those sides is 19. Quick check, plug it in again. 5 times 4 is 20, minus 1 is 19. So it definitely checks out. It looks like the length of each of those sides on the hexagon are going to be 19. Moving it to the bottom of the page. I'm going to classify another polygon here. Remember, classify it by the number of sides. So what's the special name I can get it because I know how many sides there are. So how many sides are on this shape? Well, it looks like there's 4, right? So if it's 4, I'm going to call it a quadrilateral. Remember, don't try to get any more specific than that right now. We're just generic by its sides. It says tell whether this polygon is equilateral. Is it equilateral? Does it all the sides, are all the sides marked equal? No, it doesn't work. How about equiangular? Do all the angles have the exact same marking? Nope, some have 1 and some have 2. So definitely not the same, right? So that's not true. If you get a no on both of those, you can't be regular either. So my final answer is just quadrilateral. I can't be more specific than that. All right. Number 4 says these two expressions represent the measure of two of the congruent angles in example 3. Remember, we had this hexagon, and because it's regular, right? I'm going to try to draw it, but don't laugh when it's not great. Okay, all these angles are also congruent, because as soon as it's regular, the sides are congruent, the angles are also congruent. So I could put 4x plus 8 on one angle, I could put 5x minus 5 on the other. But the important thing is if they're equal, I can have an equation part equals part again. So I get 4x plus 8 equals 5x minus 5. Solving for x, subtract 4x, I get 8 equals 1x minus 5, add 5, and x equals 13. Did my question ask me for x? No, it says find the measure of an angle. So I need to plug it in. 4 times 13 plus 8. Well, 4 times 13 is 52, plus 8 makes 60. There's one of my angles, 60 degrees. I could double check it by plugging it in again, right? 5 times 13 minus 5. That's 65 minus 5, so I get another 60. Doesn't matter which one I plug it into, I should get the exact same answer, and I can double check it by plugging it into both. Okay, I know the page ended here. I hate to waste the back of a paper, so let's flip it over. I have one more I want you to see before I turn you loose on your homework. And again, sometimes the reason I do these is I know that you might want this example when you get to your homework to make sure you know how to do this. All right, I have a triangle here. What kind of triangle do I have? Well, it looks like I have these tick marks on everything, which means I have an equilateral triangle, right? And if I have an equilateral triangle, my sides are equal. Part equals part. So I'm going to set these equal. 2x squared plus x minus 11 equals x squared plus x plus 5. Wow, this is some algebra I haven't seen yet, or at least not for a while since algebra. I need to get my like terms together, right? So I'm going to move my x squareds together. This one's smaller, so I'm going to subtract x squared. 2x squared minus that invisible 1 on that x squared leaves me with 1x squared plus x minus 11 equals x plus 5. These two canceled. Now to get those x's together, I'm going to subtract x. Ooh, that's kind of nice, right? Beautiful things happen. I have my x squared, I'm dropping the 1 there. These cancel, minus 11 equals these cancel. Wow, we're getting rid of things here. That makes it nice. All right, I'm left just with x squared. So let's get that by itself as much as possible. Add 11 to the other side. X squared equals 16. Take the square root, and x equals 4. I know that x does equal plus or minus 4, but remember, we're going to just stick with that positive value of 4. When I plug it back in, I can see this. 4 squared is 16, plus 4 is 20, plus 5 is 25. I can plug in the 4 over here. 4 squared is 16 times 2 is 32, plus 4 minus 11. 36 minus 11, 25. Definitely gave us equal sides there when x equals 4. Okay, so just be careful. Don't be scared when you see the x squared. Just, again, do the algebra you know how to do, and it should be fine. So for homework, we are on page 44 through 45, 3 through 30 all. Some of these you're going to fly through really quickly. A few of them you're going to need to solve for x like we just did. So take your time when needed. Show me your work. When it's not needed, just answer the question they're asking you. If you have questions, please send me an email.